Human body temperatures have a mean of 98.20 and the standard deviation of 0.62 degree. Convert the given temperature to z-score. Let's first define the formula of z-score. For the sample, it's x minus x bar over number of standard deviation, so that's z-score. For the sample. Now for population, we just use a different symbol, and that's mu, but then there is still the mean, except this time it's a population mean, and we have, oh, my mistake, there should be small s, and then we have a Greek sigma, and this is z-score for the population. Now let's determine whether this is the given data is a population or a sample. It just make a general claim that human body temperature have mean of 90.20, so we're gonna go with the population. So we're gonna use this formula specifically. So let's start with A, 100 degrees. So that's the data value. 100 minus the mean was 90.20 over 0.62. Let's see where it lies. So 100 minus 98.2 and then divided by 0.62, and I get 2.90. And for B, same thing, except I just have to replace the x. 96.96 minus 98.20 over 0.62 degree. So we expect negative number this time because the first number is smaller. So 96.96 minus 98.2 and then divided by 0.62. Negative 2. And finally 98.20. Well, notice that it's the same as the mean. So the top will be 0 and the z-score is basically 0. So as you can see, A and B are quite in the extreme range because the position of them is very at the extreme point, because this definitely does, it's even beyond the, it's nearly 3 sigma, and here is a, I'm sorry, yeah, nearly 3 sigma from the mean, and this is 2 sigma from the mean. So this will be far left and this will be far right. So part A is on the far right and part B is on the far left, and C just happened to be at the mean. So there's not much variation for this data value.